Hi all, welcome to the session of Introduction to Electronics Engineering under the code BESCK 104 or 204C. So whenever we hear the word electronic, what pops up into our mind? Exactly, every day for one or the other activities, we make use of one or the other type of electronic gadgets for our smooth functioning. Isn't it? So whenever we make use of any electronic gadget, we are going to use, we have to have the knowledge how to use it, how to turn it on, what are the requirements basically that electronic gadget requires, isn't it? So let us take the example of our mobile phone. So we keep using our mobile phones and suddenly there is an indicator telling that the battery is getting down. What we do? Quickly we go and we are going to charge the battery, isn't it? So that for the rest of the day we can use it smoothly. So this is how each and every electronic gadget in one or the other way requires a different type of supply, isn't it? So similarly, let us take an example. You might be thinking, as an electronic student, as a mechanical engineer, as a civil engineer or as a computer science engineer, how I am going to be benefited by going through this subject of Introduction to Electronics. What is necessary for me to study this subject electronics? Yes. So let us say as a computer engineer, we know that whenever we are going to start the computer, what we are going to do, the first thing, we are going to switch on the power supply. Yes. So we want the computer to start its operation or start its performance. So basically we require a source of supply. So to have an idea about that, we have to know the subject of electronics. Similarly, as a mechanical engineer, we are planning to design, in the future you are planning to design some of the automobiles, let us say. So for an automobile to initiate or to start its operation, to start an engine, we require one or the other type of power supply. Yes. Similarly, as a civil engineer, you are going to construct a structure, a single room or a building. Then we require to illuminate whatever the building or the structure we have designed. So there we have to get a basic idea of the different types of illumination or the different methods available. So that is where this subject electronics plays a major role in the life of every engineer. So coming back to the subject of Introduction to Electronics Engineering. So the first module that we are going to discuss is mainly about the power supplies. So power supplies, as we have come across, we know that in one way or the other, we require a power supply. So you might be aware there are different types of power supply, mainly AC as well as DC. Yes or no? So, and we have a knowledge that whenever we are for a domestic purpose at our homes, we are going to make use of the AC supply. And for all the electronic gadgets that we are going to use at home, we are going to charge using that AC supply that we are going to receive from an electric pole. So that is nothing but the AC, alternating current. Similarly, not all the electronic gadgets will make use of this alternating current. Similarly, there are some different ways of or the different gadgets which we are not going to carry the wire everywhere we go. Yes or no? So what we are going to do, we have few devices which works on the DC power supply. So one way or the other, we are going to make use of a block that is known as a power supply in our day-to-day applications or in our day-to-day electronic gadgets that we are using, or in the part of the design and development in our respective branches. So that is where this unsung hero of electronics, that is, we are not going to tell it everywhere, but this is the main block that should be used for any of the electronic gadgets. That is why we call it as the unsung hero of electronics. Yes, so let us see what is this unsung hero, how it's going to perform, what are the different characteristics that is required for this power supply. So let us take the example of our mobile phones itself. So we are using it Now our battery it is being indicated that it is going low. So what we do? We quickly connect it to the switch point or the power point at our homes or our workplaces. So what is the power supply we are receiving? Usually it is 220 volt supply. Yes. So let us say first we are going to make use of, we are going to switch it, connect it. So the voltage that we are going to make use here, that the voltage that we are going to connect is to a 220 volt, a high voltage AC, isn't it? So here we are going to make use of a high voltage AC. But do you think our batteries in our mobile phones require 220 volt? No. It depends on the different type of mobile handsets that we are using. Some of them take around 18 volts and some of them consume around 20 volts. So we don't require a 220 volt, a high voltage AC. So we need to reduce it to a low voltage AC depending on what type of gadget or what type of application we are going to use. So we have to convert the high voltage AC systems to a low voltage AC system. So there we are going to make use of a transformer, that is the step down transformer. So a step down transformer converts a high voltage AC to a low voltage AC. What about the frequency? The frequency will be the same. It does not change in case of a transformer. Now we have converted the high voltage AC to a low voltage, let us say around 20 volts. From a 220 volt, we are going to convert it into a 20 volt level of voltage. But now the mobile sets that we are going to use is made up of a battery. We are going to connect a battery, isn't it? So battery means we already know that it is a source of DC supply. So when we say that it is a source of DC supply, what do we need to do? This is the AC supply we are going to get. So we require a DC voltage. So we are going to convert from AC to a DC level of voltage. How do we convert it? By making use of a converter circuit known as the rectifier. So this rectifier circuit is the circuit that is responsible for changing from alternating signal to a steady signal. Yes, so this is the rectifier's job, is to convert a low voltage AC to a DC level. But the voltage that we are getting out from a rectifier will be always with some ripple content. So we can also call it as a unregulated DC. We have few ripple contents present in it. Now what we have to do? We have to smoothen it, because we know that whenever we say a DC source, it will always be a steady source. So steady source means there should not be any variations. We have to get a smooth waveform. So in order to smoothen it, what we are going to do? We are going to convert this unregulated, or we can call it as unsmooth DC, by making use of a suitable smoothing circuit or a reservoir circuit. Smoothing circuit or a reservoir circuit, we are going to convert the unsmoothed DC to a smooth DC. So here we are going to convert it from an unsmooth to a smooth DC. After we do this, we have smoothened the waveform, we require a particular voltage. 20 volt means exactly we require 20 volts to be applied across the battery that is present in our mobile phones. So we have to use suitable regulators in order to convert this smoothened DC to a level that is required. We require a suitable level for converting. We require a suitable level of voltage that is required for our batteries that are present in our mobile phones. So we have to use suitable voltage regulators in order to get what we say. Whenever we say a DC supply or a power supply, we say it is a regulated supply. Regulated supply means exactly the value or regulated voltage that is applied across the particular electronic gadget. So this is the general block diagram of a power supply system. So this, let me brush it up once again. Whenever we are going to make use of a power supply, the first thing that we need is a step down transformer, because for the electronic gadgets that we are going to use, we don't require a high voltage level. Depending on the suitability of that particular gadget, we need to convert it to that level of voltage. But in common, we are going to receive 220 volt to our homes. Okay, so what we are going to do, we don't require this level of voltage. So the first converter that we are going to use, so the first device that we are going to use is a step down transformer that converts the high voltage AC to a low voltage AC. Now this AC is not required because we are going to make use of a battery in our mobile. So we need to convert it into DC. That is why a low voltage AC is converted into an unsmoothed or unregulated DC, that is known as a rectifier circuit. In order to smoothen the waveform, suitable smoothing circuits. Later we will discuss, when we are studying about this, how we are going to make use of the various elements and we are going to smoothen up the waveform. So suitable smoothing circuits have to be used, as well as after the smoothened DC output is available, we require a regulated output, and that regulated output is done by making use of suitable voltage regulators. Then finally we are going to get a regulated DC power supply. This is the general block diagram of a power supply. Later now we will see what are the various components, principal components that we can use in this power supply unit. Now let us see the block diagram with making use of its principal components. So here, in order to convert the high voltage AC to a low voltage AC, we know that with the less number of turns, we have to make use of the step down transformer. So that is a step down transformer that we are going to implement in the conversion of the high voltage AC to a low voltage AC. Similarly, once the AC low voltage is available, so we have to convert that into the suitable DC voltage. We can have the rectifier circuit depending on various aspects. If we are going to make use of one single diode, we call it as a half wave rectifier. If we are going to make use of 2 or 4 diodes, we call it as a full wave rectifier. So suitable rectifier circuit has to be used in order to convert from AC to DC systems. Once we have got this unsmoothed, as I said previously, as soon as we are going to get the output from a rectifier, it will always be with a ripple content present along with it. So in order to reduce this ripple content, we have to make use of suitable reservoir circuits, or we make use of the capacitors in order to filter out and smoothen the waveforms. So we are going to get an output as a smoothed DC. Next, we are going to make use of a Zener diode. This Zener diode is going to help us to regulate the level of voltage. Up to which level that is exactly required for that particular application or an appliance, that we are going to regulate using a Zener diode. So then we are going to get a regulated DC power. So this is the block diagram which makes use or which shows the principal components that we are going to make use for a power supply. Next, we will discuss about the various types of rectifiers that we have. Thank you. In the previous session, we have already discussed about the rectifiers as the main block in a power supply system. So what is this rectifier? A rectifier is a type of converter that converts the AC signal into its DC signal. So this is a working of a rectifier circuit. So in this rectifier circuit, mainly based on a special device, we tell the different types of rectifier circuits. That special device is our diode, which we all have come across. We know what is a diode and how it works. So before we get into the details of the main element in the power supply unit, the rectifiers, let us first have a brush up on what is this diode and how it is going to turn on and off. So we know that whenever we speak with a diode, it has two regions. One is the P region and the N region. So in the P region, as we know, we have excess of holes that are present in a P region. Similarly, in case of a N region, we have excess of electrons present in case of a N region. And the terminal across the P region is known as the anode, whereas the region, the terminal around this N region is known as the cathode. And we also know that we have a junction barrier present in between two regions. Now, whenever we say the diode is to be going in its or the diode is to be in its on state, we know that whenever we are connecting the anode to a positive potential and the cathode to a negative potential, then what happens? Then this positive potential and the holes present inside the P region, they are like charges. So these holes that are present in the P region moves away from the potential and starts accumulating at this barrier potential. Similarly, here we are going to apply a negative potential. So when we are going to apply a negative potential here, the electrons that are present in the N region is moving away because we know the like charges repel each other. So these electrons break the barrier and makes an electron hole pair with the holes present in the P-N junction, and this is when a current is said to be flowing from the anode terminal to the cathode terminal, and this is a state when we are connecting anode to positive and cathode to negative. We call the state as a on state. Similarly, when we are going to give the opposite potentials, anode is connected to negative potential and cathode is connected to positive potential, then what will happen? Negative potential, holes are present, so these have a property of attraction, so the holes are tending towards this negative potential. Similarly, negative electrons are present here in the N region and we are applying a positive potential here. So there is a force of attraction. So all the electrons tend towards this positive potential. So what happened to this gap, barrier potential? It increases. The gap between the P and the N region is high, and because of this the electrons cannot freely move to make a pair with the holes. Hence there is no current flow and the diode is said to be in its off state. So this is how a diode goes on as well as turns off when we are going to apply the different potentials across the P and N regions of a diode. So based on these operations of a diode, we have classified the rectifiers into various types. One is the half wave rectifier and the other one is the full wave rectifier. So first let us discuss about what is this half wave rectifier. So half wave rectifier, here what we are going to make use is, what is a rectifier? Rectifier converts AC to DC. So we are going to make use of only one half wave that is present in a total. A sinusoidal wave means we have a positive half cycle, we have a negative half cycle, isn't it? So together one positive and one negative forms one cycle in a AC signal. In that we are going to make use of any one half of the sinusoidal signal. So that is why we call half wave. And whenever we are using one half of the cycle, then only one diode is sufficient in order to turn it on. So already we have understood what is the working of a diode. Now let us see how this diode is going to play its role in a half wave rectifier circuit. So we are going to give a 220 volt AC? Yes. We are going to connect it to the supply. So we are going to use an input V in, let us call it as V in. That is nothing but a AC power supply which is having 220 volts. Usually the frequency that we use is a 50 hertz, is applied across the terminals of a transformer, to the primary windings of a transformer. Since we are calling it to be a step down transformer, we have to show the number of turns in a primary side as more number of turns. Similarly, at the secondary side of the transformer, since we are showing a step down from 220 approximately to 20 volts, we are going to reduce it. So you have to show the turns ratio as very less number of turns. This is how you represent a step down transformer. Right? Now, from 220 volt approximately we are going to get some 20 volt across the secondary side. So this part is the step down transformer. Now what we are going to do, let us use one single diode in this direction. This is the anode of the diode and this side is the cathode of the diode. So this is the direction of the diode that we are going to place. So we have the supply, we have a device to switch it on and off. Then to complete an electrical circuit, we require to have a load element. Let us consider a simple resistor to be acting as a load element. Okay, with some resistance R, load resistance R. So whatever the output we are going to get across these terminals, this is the output voltage. Let us call it as V out. So this is the circuit for a half wave rectifier. I hope you have understood how we are going to write the circuit and its different components. Now during the positive half cycle, let us see what happens during the positive half cycle. So during the positive half cycle, I will write from the secondary side. So during the positive half cycle, let us say this is the positive half and here we have the negative. So we have a diode that is present here and the load resistance that is present here. So during positive half cycle, what happens to the diode? Anode is connected here, cathode is connected and we have the load resistance. So anode is connected to positive and cathode is connected to negative. So we already said that if the anode is connected to positive and cathode is connected to negative, the diode will be in its on state. Similarly, here also in the circuit of half wave rectifier, the diode is going to be in its on state. So when the diode is going to be in its on state, we represent the diode as a short circuit. Short circuit will be represented. Means it allows the current to pass through it and hence the current flows here and we are going to get the output voltage when the diode is connected or in the positive half cycle. Similarly, in the negative half cycle, what happens? Let us analyze that. So in the negative half cycle, here let us say it is negative and this is positive. So here we have a diode and we have connected a load resistance RL. So what happens here? When anode is connected, let us say this is anode and this is cathode. When anode is connected to the negative terminal, what happens? When anode is connected to negative, there is a wide barrier gap between the P and N regions. So there is no current flowing through it. So it is in the off state. So when it is in the off state, we represent it as an open circuit. So in case of an open circuit, the diode is as open. So in case of open circuit, we know that when a device or a diode is in the open circuit, there is no path for the flow of current. So here there is a current flow I, but here there is no current flowing. So will you get an output? There will not be any output. So this is how during one positive cycle and one negative cycle, the behavior of the diode varies. Correspondingly, in positive half cycle we are getting output, in negative half cycle we are not getting any output because there is no current flowing in the circuit. So this is how, let us represent this in the form of a waveform. So now let us draw the waveforms for this half wave rectifier circuit. So first one, what is the input we are going to apply? The input that we are going to apply is a AC signal. So with respect to omega t, AC signal, positive cycle, negative cycle, positive cycle, this continues. One positive, one negative is one complete cycle. So we will write 0, pi, 2 pi, 3 pi and so on. So with some amplitude Vm and minus Vm. Now due to the switching action during the positive half cycle, what happens? During the positive half cycle, because of the conduction of the diode, so let us call this as the diode D1. So because of the conduction of the diode D1, we are going to get an output in the positive half cycle. So let us say this is the waveform for the output voltage V0. Okay. So during D1 what happens? During D1 the diode is conducting and we are going to get an output voltage. So here we are going to get the output voltage because of the conduction, switching action of diode. During negative half cycle what is happening? During negative half cycle there is no path for the flow of current because the diode is acting as an open circuit condition and hence the output is 0. We are not going to get any output during the negative half cycle. Similarly, for the next positive half cycle what happens? Again the diode D1 switches on and because of the switching action of diode we are going to get an output voltage because of diode. And this is how we are going to get a rectified output. So this is about the half wave rectifier circuit. Its circuit diagram, the different conditions during the different cycles of a AC waveform, and this is the waveform representation of a half wave rectifier. Only one half we are going to use it for the conversion, AC to DC conversion. Okay. Now as I told you, already as we have seen in the block diagram, it is an unsmoothened waveform, isn't it? Whenever we say DC, we think of a straight line as the output. But here what is happening? We have an unregulated system. So in order to make this as a regulated smoothened waveform, we have to make use of a reservoir components like a capacitor. So where we have to place the capacitor? Capacitor has to be placed in parallel with the load element. Here the resistor is the load element. So in parallel to this, we have to place the reservoir or a smoothing circuit. So let us see the half wave rectifier, how we can modify it by placing a smoothing filter. So this is the circuit for a half wave rectifier with a smoothing circuit or a reservoir capacitor. Now let us see how it is going to operate. So when during the positive half cycle, as we have already seen, during positive half cycle diode is in the on state, so diode is forward biased condition and hence there is an output across the resistance, load resistance RL. During this time what happens? The capacitor starts charging. So here the capacitor starts charging and we are going to get the output voltage across this. Diode is on, there is a path for the flow of current, so the capacitor in turn gets charged. Now during the negative half cycle, this is for the positive half cycle. During the negative half cycle what happens? This is the secondary side, that is the input side, secondary terminals of the transformer. The diode is open circuit. Because diode is in the reverse bias condition, there is no path for the current to flow, so the diode is open. Now what happens? Whatever the capacitor had already stored the charges, now it will start discharging through the resistor. right? Because of this discharging nature, it is a quick discharge. It does not take a long duration of time depending on the value of RL into C, that is a discharging time constant. The capacitor is quickly discharging and there will be a output available, not because of the diode but because of the capacitor, the reservoir element, that is already it had stored the charges during the positive half cycle, and we know by nature of its basic nature of a capacitor is it has to store the charges, then it has to release back whatever it has stored. That is the basic nature of a capacitor. So during the negative half cycle, when the diode is not functioning, when the diode is not allowing the current to flow, this capacitor discharges through the resistance with some discharging time constant, that is calculated as R into C, and because of this we are going to get a continuity. So now let us see how the waveform changes. Now we know this is the input that we are applying, sinusoidal input. So positive negative half cycle keeps on repeating. Now during the positive half cycle, diode is charging. Similarly the capacitor is also charging till the maximum value. Now diode is going to go to its reverse bias condition. When it is going to go to the reverse bias condition, what happens? It will slightly discharge up to some value, not fully to 0, it has to be continuous. Again it will continue charging, then again it will slightly discharge, right? So this is how, see the waveform, previously it was completely 0, a 0 line, again the waveform is a discontinuous waveform, ripple content, but here you can observe that the waveform has been smoothened. Why it has been smoothened? Because of the smoothing filter, that is a capacitor filter is acting as a smoothing element, so we are going to smoothen the waveform. This is how, by adding an extra capacitor in case of a half wave rectifier, the waveform is being smoothened. I hope you have followed how the half wave rectifier works, and by making use of a reservoir capacitor, how we have got the continuity in its waveform. Thank you. We have discussed about half wave rectifier, and we know how a diode is going to, by its switching action, is going to give us the output only for one half cycle. Now let us speak about the full wave rectifiers. So as the name itself indicates, we are going to make use of a complete cycle, both positive half as well as the negative half cycle, and we are going to perform the rectification action, and hence we call it as the full wave rectifier. Now while discussing the full wave rectifier, actually when compared to the half wave rectifiers, this is more efficient. This is more efficient as it is going to use both the cycles, because of both the cycles for its operation, and here the demand of the reservoir or the smoothing filters that we use is slightly less when compared with the half wave rectifiers. So here in case of full wave rectifiers, again we have two forms of representation of a full wave rectifier. So which are they? They are biphase rectifiers. We have two types. One is the biphase rectifiers and the other one is the bridge rectifiers. So these are the two forms of representation of a full wave rectifier. Now the first one, let us see how a biphase rectifier works. So a biphase rectifier, in this we are going to make use of a transformer with its primary winding connected to the input 220 volt AC supply, 220 volt, 50 hertz, that is connected through the secondary windings with less number of turns, but the speciality here is we are going to tap it at the center, and we call such type of transformers as a center tapped transformers. See, primary winding was there, but secondary winding we are tapping at the center and we are going to connect it. So this type of representation is known as the center tap transformers. So if we are going to make use of a center tap transformer and the number of diodes that we are going to use is only 2 diodes. So by making use of 2 diodes and the center tap transformer, that is a turns ratio has been distributed. So this type of transformer makes use, then we call such type of rectifier circuits as a biphase rectifiers. So here we are going to make use of 2 diodes, diode D1 and D2, and the load resistance that we are going to connect is here. That is, the diodes, the cathodes of the 2 diodes are short, and that end is given to the resistance, load resistance, and the other end of the load resistance is obtained from the center tap transformer. So this is where we are going to see the output voltage, right? Now the diodes have been phased like this. So during the positive half cycle, so this is the general diagram, this is a general diagram for a biphase rectifier. Now let us see during the positive half cycle how the diode behaves. Okay. So I will write it from the secondary side. 2 windings have been tapped, and see here during the positive half cycle, this is how the voltage will be in the form of its sign, positive, negative, positive, negative. So this will be connected to the diode here. This is the diode D1, and here we have the diode D2. So these two are connected to a load resistance, and this is again connected to the load resistance. So during the positive half cycle, what happens? During the positive cycle, positive is connected to anode, so hence there will be a short circuit, there will be a path for the current to flow through it. Similarly here negative is connected and anode terminal is present, so here it will be open circuited. So the path for the flow of current we are going to choose from here to here. Not because of diode D2, it is only because of diode D1 there is the output available here across the load resistance. Similarly, during the negative half cycle, what happens? Let us see here through the diagram. So during the negative half cycle, diode D1 is connected here. Then we have got the load resistance. From this diode to the next diode, we have the connection here. Yes. So this is our diode D1, this is our diode D2. Now during negative half cycle, what happens? During negative half cycle, the secondary windings of the transformer becomes minus plus and minus plus. Now minus and anode is present. So minus and anode if it is present, yeah, here it is going to be the reverse bias condition, that is the off state of the diode. So here in this condition the diode will become open circuit. There is no path for current to flow. Whereas come back to this diode D2, the diode D2 positive is connected to the anode terminal, and hence there is a path for the flow of current. So hence the diode flows, comes back here. So this is responsible for the output voltage across the resistance, load resistance. So during positive half cycle as well as during the negative half cycle, let us see along with the waveforms for the positive and the negative half cycle. So this is the input voltage. So the input voltage that we have consists of positive, negative, positive cycles. So 0, 180, 360, 3 pi, plus and minus Vin. So during the positive half cycle and during the negative half cycle, what happens? So during the positive half cycle, what is responsible? Diode D1 is responsible, and we are going to get the output as D1. This is the output waveform that we are speaking with, right? So let us say this is positive, negative, here also it is positive. See, now the direction, this is responsible diode for the conduction is diode D1, upper diode. During negative half cycle, what is happening? During negative half cycle, the diode D2 is going to conduct because of this we are going to get an output. See, the output that we are going to get is takes this path and here it flows from positive to negative only. So the diode, the direction of the output does not change, it is same, comes back to the center tap point. So here also we are going to get an output, but this output is by the responsibility of the diode D2. Clear? So next the cycle repeats. So again we are going to get an output voltage here, and this output voltage is because of the diode D1. This keeps on continuing as the cycles keeps on repeating. Output that we are going to get from a biphase rectifier. Now if we have to show, now we are again what, see again what we are getting, we are going to get a pulsating DC, but in order to filter it out, what we need to do, we need to use a capacitor for a smoothing purpose. So capacitor C1 is used. So this C1, what it does, that is always the smoothing filter must be connected across the load resistance. So this smoothing filter, what will happen during the positive cycle, what happens, the smoothing filter starts storing the charges. During negative half cycle, the smoothing filter starts discharging the stored charges, and hence the waveform that we are going to get is, it is getting smoothened. During negative half cycle, again it is going to discharge, again it is going to charge, and again it is going to discharge, and this cycle does not wait for the next negative half cycle, as the diode is going from the peak value to its reverse value. At that instant itself the discharging is quick, and because of this quick discharging, again charges due to diode D2, again discharges, again charges, again discharges. So that is how we are going to get a smoothened waveform by using a reservoir element or a smoothing element, that is the capacitor filter. So this is how the waveform changes, or it is being smoothened by making use of capacitor to the biphase rectifier.